Welcome to the Learn It channel, your go-to spot for learning Autodesk Fusion, also known as Fusion 360. In this module, we're diving right in from the start. In Module 1, Design, we'll get you up and running with the basics of the user interface, and then explore how to design using primitives and sketches. Even if you're just starting out, this lesson will give you a solid foundation for everything that comes next. Every module has 3 parts: Design, CNC, and 3D printing. If you're eager to sharpen your Fusion skills, you can find practice drawings for all modules on our Patreon. Welcome to the Learn It channel. Let's start with Module 1, Design. When you first open Fusion, this is what you'll see. What do you want to design? We're going to get to this in just a moment, so for now, hit the Cancel button. At the top, you'll find your design tools. On the left is the data panel, where your projects are stored, which you can access by clicking this little data panel toggle. Here you can see that I've actually created several projects already. If you'd like to customize the icons for these projects, please check out a tutorial we made on how to do this in the description below. At the center of the screen is the canvas. Much like a painter's canvas, this is where your digital designs come to life. On the left side of the canvas is the browser, which shows things like your components, bodies, and sketches. At the bottom is the timeline. This is where Fusion tracks every step you take in your design process. Before we begin, I'm going to reset all my parameters to default so that we all start on the exact same page. To do so, click on your profile icon at the top right, click Preferences, and then Restore Defaults. Click OK. If you'd like to change your theme or how Fusion looks, head on back to your profile, then Preferences. Here under Theme, you can select Match Device Theme, Light Gray, or Dark Blue. As a preview, let's select Dark Blue. To keep things standard across all our tutorials, I'd like to just go back to the standard theme. You can also go down to what's called the navigation bar, select Display Settings, and then select different environments, such as Tranquility Blue. Work with whatever you prefer, but please note that we're going to stick with the theme default for this entire series. Keep in mind that if you select a different environment, some of the colors of various features will be different than how I describe them. Now, always start organized. It makes larger projects much easier later on. So let's create a new project. We'll go over to our data panel and click New Project. Let's give it a name, Learn It Fusion, and then press Enter. We can pin a project by hovering over it and clicking the Pin toggle switch. Now at the top, we'll find a drop-down menu to further organize our projects. For example, by selecting Pinned, which will only show our pinned projects. Next, let's open up our project and create a new folder called Module 1. You can do that by double-clicking Learn It Fusion, and then selecting New Folder. This folder will host all our files that we'll use for Module 1. Now, let's create a new design file inside that folder. First, double-click that folder to open it. At the top of your screen, click on the plus, or go to the document icon next to our data panel, and select New to create a new design file. Here, you'll be presented with that initial window which asks, what do you want to design? If you'd like to go into more depth on each of the main design files within Fusion, then check out the video we just released. For now, let's just create a part design. In the Unit System drop-down menu, you can change between metric and imperial units of measurement. Let's select millimeter for now and click Create New. It is a great habit to save right away and save often within Fusion. So let's go ahead and save this. We'll call it Practice Part 1A. Wherever you have opened to in your data panel is where your file will be saved. You can always choose another location by selecting here. Let's go ahead and save this file. At the top of the screen in what's called our application bar, you'll see our current file along with the untitled file that was created when we first opened Fusion. Let's exit out of that. Now let's close our data panel to utilize more of our screen. Now that we understand the layout, let's start designing. Before we sketch anything, I want to show you how to create parts using what is called primitives. Now, primitives are just basic, fundamental shapes. Let's go to our toolbar to our Create drop-down menu, and here you'll see our primitives: box, cylinder, sphere, and so on. Let's create a box. The first thing we need to do after selecting our primitive is to select a construction plane. Here I can select the XY, XZ, or YZ plane. The important concept here is this: I can build the exact same part on any construction plane. The plane controls orientation, not the geometry itself, and I'll prove that to you in just a minute. Let's go ahead and select the XY plane to get started. Now, pay special attention to a message that appears to the southeast of our cursor. Just make sure to not move your mouse to see this message. There it says Place First Corner. Let's place that corner at what's called the origin. Let's click and then move our cursor to the right. Now we can enter our dimensions. Let's start off simply. As you can see, our first dimension is highlighted in blue. There it says 85 millimeters. If we start typing on our keypad, it will enter the dimension right there. Let's just type in 100, after which you'll see that it is currently locked or defined. Next, to get to the other dimension, just press Tab on your keyboard and then enter 60. Once we input both of those dimensions, press Enter to go to the next step. The next dimension that is highlighted in blue is the height. In this instance, Fusion defaults to 5 millimeters. No need to click your mouse, just start inputting your next dimension, 20 millimeters. Press Enter on your keyboard or click OK to fully create your rectangular prism. Next, head to the View cube on the top right of our canvas and click the Home button to view our home position, which will center and scale our part. Just like that, we have our first solid body. Let's talk for a moment about metric and imperial units. My practice drawings for this course are provided in both metric and inches, so you can work in whichever system you prefer. To change units for the active file, head on over to the browser, hover your cursor over units, and then select the icon that appears. Let's just select inch, for example. You can also expand the window to see all the information in this dialog window. We can set as default if desired. Some users will accidentally move the dialog window, which will unanchor it from its default location. Anchor it back into place by left-clicking and dragging the top of the window back to the right side of our screen. When you see the blue bar, release your mouse button, which will anchor it back into place. Now let's go back to millimeters, which you can see is default for me. As a bonus tip, let's see how to input millimeters or inches regardless of the units of measurement selected for our current document. Let's just go down to our timeline, left-click our primitive, and press Delete on our keyboard to delete it. Let's create another box. Select the XY construction plane. Select our origin first. Here, instead of inputting a number which will automatically be input in millimeters, I can simply input 3 followed by the double quotation mark, which means 3 inches. Press Tab and then input 2 double quotation mark for 2 inches. Press Enter and then input 1 double quotation mark for 1 inch. And there we have it. Even though our document is set to metric, we fully defined our part using inches. The same method can be used if our document was set to inches. Simply type mm after the inputted number to specify millimeters. Fusion will automatically convert everything for you, which is a huge productivity boost. Let's delete that primitive that we just created. Left-click the feature in our timeline and press Delete on our keyboard. If that doesn't work, then right-click the feature and select Delete. Let's go back to our home view to center everything. For a moment, let's talk about construction planes. Let's create another box. What we now see are our 3 base construction planes. Again, you're not locked into any one plane. You can build the exact same part from different orientations depending on your design intent. In fact, let me prove that to you right now. We first created our part on the XY construction plane. How do we know it's called the XY construction plane? Well, look at our view cube. Each line color represents an axis. The red line is the x-axis. The blue line is the z-axis. If we click and move the view cube, we can see that the green line is the y-axis. Here's some correct terminology. We say one axis and two or more axes. I know it sounds funny, but it is correct. Also, always name your planes alphabetically. That is, X comes before Y, Y comes before Z. Pros say the XY plane and not the YX plane. Same with the XZ plane and not the ZX plane. You'll sound more professional if you use correct terminology. Now let's make the exact same part by clicking on the XZ construction plane. Place your first corner at the origin, move your mouse cursor off to the side. The highlighted dimension will now become our height, input 20. Press Tab to select our next dimension and input 60. Press Enter. Then input 100. Note that the definitions in our dialog window don't change to our current design because they're based off of the construction plane that we just selected. Therefore, what was length in our previous part is now the height. Don't worry about this too much. You'll get used to selecting the correct plane based on your design intent, and many times won't even look at that dialog window in the future. Here's some practice. Create this exact same part, but by first selecting the YZ plane. Make it look the exact same when you hit the home button of your view cube. Before we move on, let's talk about zooming, panning, and orbiting. I highly recommend getting a good mouse with minimum 3 buttons and a mouse wheel. A couple recommendations have been included in the description. If you're using a Mac and are only using a Magic Mouse or trackpad, then I still highly recommend getting a better mouse. A cheap mouse with buttons and a wheel will help keep your sanity within Fusion. We can zoom out using the mouse wheel. If you find that zooming is not going in the direction you like, then head on over to your preferences, scroll down and select reverse zoom direction. Now the direction of zooming is much more intuitive for me. To pan, click the middle mouse button and move your mouse. Sometimes the scroll wheel can be pressed down, which is your middle mouse button. Finally, hold Shift on your keyboard plus middle mouse button and then move your mouse to orbit. Select your home view again. Now, if you are a professional and are interested in further upping your game, then I highly recommend 3D Connection Space Mouse products. I'll talk more about them in the future, but links to purchase them at various price points can be found in the description below. Now that we've created this part using primitives, let's recreate the same part using a sketch. Again, let's go to the timeline and delete our box feature. Now let's just take a look at our toolbar for a moment. All of these features are simply shortcuts. If we click the Create drop-down menu, we will see all the same tools. For example, Sketch, Extrude, Revolve, and Hole. You can easily add or remove any of these by hovering over the tool and then clicking the 3 vertical dots, also known as a kebab menu, that appear. Toggle Pin to Toolbar to view or hide that shortcut on your toolbar. You can also move each tool on your toolbar by clicking and dragging them to another location within their native grouping. Now let's create a sketch. Then select our XY construction plane. Do you remember which one that is? If you selected the one cutting through our X and Y axes, then you are correct. Great job. Once we select our construction plane, our view is reoriented to what is called normal to that construction plane. Let's create a 2-point rectangle by selecting it in our toolbar. Before clicking it, you'll notice that if I hover over it, a description of that tool will be shown, along with its corresponding keyboard shortcut key. To create a rectangle, just simply press R on your keyboard. You'll memorize all these shortcuts in no time. Now, hover your mouse to see what our first step is. It says Place First Corner. Let's do the exact same thing as our primitive and select the origin and then move up into what's called the first quadrant, which is the position between 12 and 3 o'clock from our origin point. Now, let's type in our dimensions. Input 100 in our first dimension callout. Then Tab, then 60 in our second dimension callout. And then press Enter to set everything. Finish our sketch by clicking in our dialog window or on our toolbar. The view should go back to our home view, but you can always click the home view to bring it back into position. Here we have what's called a closed profile. If I single click it, everything turns blue. This is also referred to as a watertight profile. Picture pouring water into it. None of it could escape because it is fully enclosed, or in other words, watertight. Now let's go to our extrude tool. Fusion will automatically pick that profile that we just created. You can see in our dialog window that one profile has already been selected. Click that same profile to deselect it. Let's make sure that it is selected and then grab the arrow in the direction that you would like it to extrude. Let's go in the positive Z direction and then input 20. Press enter to set it. Again, if you need to reorient it to your home view, feel free to click that now. Now we have the exact same model, built a completely different way. I said early on that it is a good idea in Fusion to save often. Let's take this moment to save our design file, and we can do that on our application bar by clicking Save. For the last skill taught for this particular module, we're going to talk about parametric editing. In our timeline, you'll see the tools or features that we just used to create the part we see on our screen. We have a sketch feature and an extrude feature. Using what's called parametric modeling, we can change something once, which will update everywhere. In fact, the very first tool that we use to create our part is positioned where we would call it upstream. And then everything created after that, or to the right, is referred to as downstream. If we change something upstream, it will automatically affect all related features created downstream, which is the beauty of parametric modeling. Let's look at a practical example. Head to our timeline to our sketch feature. There are two ways of selecting it. We can double click it. However, many have expressed that double clicking doesn't always work for them. Or we can right click and then edit that feature. Let's do that and then select Edit Sketch. As you can see, it goes back in time or upstream. If you look carefully at our timeline, we will see that extrude is semi-transparent because we are working on a tool that was created before it, or upstream. At this point, let's change our dimensions. I'll zoom out so we can see all the dimensions. To change a dimension, double click it. Let's change the 100 dimension to 150. Then press enter. Then let's change the 60 millimeter dimension to 80, followed by enter. Now let's finish our sketch, go back to our home view, and you'll see our updated part. The part has extruded automatically to 20 millimeters in height, and now we have a completely new part. We just created two parts which were based off of some drawings. We will get to understanding how to read those drawings in future modules, but you should be able to interpret the three basic dimensions on the drawing and how they relate to the practice part without problem. If you'd like further practice drawings for this and each subsequent modules, please head on over to our Patreon page. For each tier of membership, you'll find practice drawings to dramatically improve your understanding of Fusion, drawings, and design in general. And they will be provided in both metric and imperial units. So, congratulations! That completes Module 1, Design. But don't go anywhere yet. In Module 1 CNC, we'll machine this exact part on a 3-axis vertical milling center. In Module 1 3D Printing, we'll prepare it in Bamboo Studio and print it using my Bamboo Lab 3D printer. Please consider subscribing and hitting the notification bell to stay up to date with these modules, since every lesson will progressively teach you on your way to becoming a Fusion expert. Just so you know, I'm not sponsored by Autodesk or Bamboo Lab. I'm an independent content and course creator that just loves CAD/CAM and teaching. So if you'd like to support this channel, please consider becoming a Patreon or YouTube member, where you'll also get access to bonus tutorials. Patreon members get the added benefit of having access to practice drawings, technical resources, and much more. And at this point, we just want to give a huge shout out to all of our titanium tier and higher members. Thank you so much for your generous support and your ongoing encouragement. We appreciate it greatly. Supporting us is a win-win and can help me continue to produce full structured courses like this. So if they're up on the screen now, head on over to the CNC or 3D printing tutorials. If Module 2 is released, you'll see that too. If they're not up yet, you'll see some other tutorials previously produced by us. Thanks for learning Autodesk Fusion with the Learn It channel. I'll see you at the next lesson.